Right now, you're using the internet, maybe watching this video, scrolling through social media, or checking your email. But have you ever wondered how all this actually happens? How does a video, stored on a server thousands of miles away, appear on your screen in just seconds? Today, we're going to unravel the mystery of the internet in the simplest way possible. No confusing jargon, no complicated diagrams, just a clear, engaging explanation that will make you say, "Oh, so that is how it works." By the end of this video, you'll understand what the internet is, how data travels, what IP addresses and DNS do, and why your internet speed might be different from your friend. Let's start with the basics. What exactly is the internet? In simple terms, the internet is a massive global network of computers, all connected together. Imagine a giant spider web with millions of threads linking billions of devices around the world. It's like a huge road system, highways, streets, and tiny lanes, connecting every city, town, and house. But instead of cars, it's data traveling through these digital roads. The internet began in the 1960s as a U.S. military project called ARPANET, and today, it connects over 5 billion people worldwide. It's the invisible infrastructure that powers our digital lives. To make sense of the internet, think of it like a massive road system. Highways, streets, and alleys connect every place on Earth. The internet works the same way, but instead of cars, it's information, your messages, videos, and emails traveling along these routes. When you send a message or watch a video, your data moves through this digital road network, hopping from one device to another until it reaches its destination. This analogy helps us understand how everything is connected and why the internet can reach almost anywhere on the planet. You might think the internet is all wireless and invisible, but it actually relies on a huge network of physical cables. These cables run underground, across cities, and even under the ocean. In fact, over 400 undersea cables carry 99% of all international internet traffic today. Wi-Fi and mobile data are just wireless ways to connect to this same network. So every time you send a message or stream a video, your data is likely traveling through miles of real, physical wires before reaching its destination. Now let's talk about how your data actually moves across the internet. Whenever you send a message, watch a video, or open a website, your device breaks all that information into tiny pieces called data packets. Think of it like slicing a big pizza into small pieces so it can fit through a small door. Each packet is labeled with the sender and receiver's address and then sent out into the network. These packets might take different routes to reach the same destination, but once they arrive, they're reassembled into the original message or video. Let's follow a data packet on its journey. First, your device breaks the data into small packets. Each packet gets a label with the sender and receiver's address. Then these packets travel through a series of routers, devices that direct the traffic across the network. Different packets might take different routes, depending on which path is fastest or least congested. Finally, all the packets arrive at the destination and are reassembled into the original message, video, or website you requested. A router is like a traffic police officer for your data. It looks at each data packet and decides the best route to send it forward. Your home Wi-Fi router does this too. It connects your devices to your internet service provider, ISP, and helps direct your data to where it needs to go. Routers are everywhere, from your living room to giant data centers, making sure that every packet finds its way across the digital highways of the internet. Every device on the internet has a unique address called an IP address. It's just like your home address. Without it, nobody knows where to send your data. An IP address looks like a set of numbers, for example, 192.168.1.1. This number identifies your device on the network, making sure your messages, videos, and emails reach the right place. Without IP addresses, the internet would be total chaos. DNS stands for Domain Name System, and it solves a big problem. Humans remember names like Google.com, but computers only understand numbers like IP addresses. DNS acts like a giant phone book for the internet. When you type a website name, your device asks DNS, "What is the IP address for this site?" DNS replies instantly with the correct number, and your browser connects to the right server. Without DNS, we'd have to memorize long strings of numbers for every website. Let's see DNS in action. When you type a website name into your browser, hear what happens. First, your device sends a request to the DNS server, asking for the IP address of that website. The DNS server looks it up and sends back the correct IP address. Your browser then uses that IP address to connect to the website's server and load the page. All of this happens in a split second, making the internet easy to use for everyone. Have you ever wondered why your internet speed is faster or slower than someone else? There are several reasons. The type of connection matters. A fiber optic cable is much faster than old copper wires. The distance from the server also affects speed. The closer you are, the faster your connection. Network traffic plays a role too. More users mean slower speeds, just like rush hour on the roads. Finally, your internet service provider and your device's hardware can make a big difference. Fiber optic cables are the fastest way to send data. They use light signals, which travel almost at the speed of light, making internet connections incredibly fast. In contrast, older copper cables use electrical signals, which are much slower. Think of fiber optic as a bullet train and copper cables as a bicycle. This is why areas with fiber optic connections enjoy much faster internet speeds. Big companies like YouTube and Netflix use something called a content delivery network, or CDN. CDNs store copies of videos and other content on servers all around the world. So when you press play, the video comes from the nearest server, not thousands of miles away. This is why YouTube loads so quickly, no matter where you are. CDNs help make the internet faster and more reliable for everyone. Let's quickly recap what we've learned. The internet is a global network connecting billions of devices. Data travels in small packets, routed through cables and routers across the world. Every device has a unique IP address, like a home address on the internet. DNS translates website names into IP addresses, making it easy for us to use. And internet speed depends on connection type, distance, network traffic, and hardware. Now, you have a clear picture of how the internet actually works. The internet is one of the greatest inventions in human history. It connects people, enables instant communication, and gives us access to a world of information. From streaming movies to learning new skills, the internet has transformed the way we live, work, and play. Understanding how it works helps us appreciate the technology we use every day. The internet's journey began in the 1960s with ARPANET, a U.S. military project designed to connect computers for research and communication. Over the decades, it grew from a handful of computers to a global network connecting billions of people. Today, the internet is essential for everything from business and education to entertainment and social connection. Most people don't realize that the internet relies on a vast network of undersea cables. These cables, stretching across oceans, carry almost all international internet traffic. Without them, global communication would be impossible. Next time you send an email overseas or watch a video from another country, remember, it's probably traveling through one of these hidden cables deep beneath the sea. While cables form the backbone of the internet, most of us connect wirelessly using Wi-Fi or mobile data. Wi-Fi lets you connect devices at home or in public places without wires, while mobile data uses cell towers to connect your phone to the internet. Both methods ultimately link you to the same global network, just without the need for physical cables in your hands. Routers are constantly making decisions about the best path for each data packet. They consider factors like congestion, distance, and speed. If one route is busy or broken, the router sends the packet along a different path. This flexibility keeps the internet running smoothly, even when parts of the network are overloaded or offline. The internet uses a method called packet switching. Instead of sending all your data in one big chunk, it's broken into packets that travel independently. This makes the network more efficient and resilient. If one packet is delayed or lost, the others can still get through, and your device can request any missing pieces. Packet switching is a key reason the internet is so robust. IP addresses are like digital home addresses. Every device on the internet gets a unique number, ensuring data is sent to the right place. When you visit a website, your device uses its IP address to request information, and the server uses your IP to send data back. This system keeps everything organized and ensures your messages don't get lost. DNS makes the internet user-friendly by translating website names into IP addresses. Without DNS, we'd have to remember long strings of numbers for every site. Instead, we just type names like YouTube, com, and DNS handles the rest. This system keeps the internet accessible for everyone, no matter their technical background. Fiber optic cables use light to send data, which means information travels at nearly the speed of light. This makes fiber internet incredibly fast and reliable. In contrast, older copper cables use electrical signals, which are much slower and can be affected by interference. That's why upgrading to fiber optic can make such a big difference in your internet experience. Content delivery networks, CDNs, store copies of popular content on servers around the world. When you request a video or website, the CDN delivers it from the closest server, reducing delays and speeding up loading times. This technology is why streaming services and big websites can serve millions of users quickly and reliably. Just like roads can get crowded during rush hour, the internet can slow down when too many people are online at once. This is called network congestion. Routers and ISPs work hard to manage traffic, but during peak times, you might notice slower speeds. Understanding this helps explain why your connection might be faster late at night or early in the morning. Your Internet Service Provider, or ISP, is the company that connects your home or business to the internet. ISPs manage the connection between your devices and the wider network, providing you with an IP address and routing your data. The quality of your ISP can have a big impact on your internet speed and reliability. The speed of your internet connection isn't just about cables and routers. Your device's hardware, like its processor and memory, also affects how quickly you can browse, stream, or download. Older devices may struggle to keep up with fast connections, while newer hardware can take full advantage of high-speed internet. The internet is constantly evolving. New technologies like 5G, improved fiber optics, and smarter routers are making connections faster and more reliable. As more devices come online and demand grows, the internet will continue to adapt, bringing even more possibilities for communication, learning, and entertainment. To sum up, the internet is a global network connecting billions of devices. Data travels in packets, routed by routers and cables. Every device has a unique IP address, and DNS translates website names into these addresses. Internet speed depends on many factors, including connection type, distance, traffic, and hardware. Now, you have a clear understanding of how the internet works. The internet is one of humanity's greatest achievements. By understanding how it works, you can better appreciate the technology you use every day. Whether you're streaming a movie, chatting with friends, or learning something new, you're part of a vast, interconnected world. And now you know exactly how it all comes together, one packet at a time.